the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No mic, no fame, just the sound we crave. Tune and turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just a vibe that's real. Faceless words you can touch and feel. In shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go.
One of my guiding principles is don't do anything that other people are doing. Always do something a little different if you can. The concept is that if you do it a little differently, there is a greater potential for reward than if you do the same thing that other people are doing. I think that this kind of goal for one's work, having obviously the maximum risk, would have the maximum reward no matter what the field may be. Seymour Cray. Seymour Roger Cray, September 28, 1925 to October 5, 1996, was an American electrical engineer and a true visionary in the world of computer architecture. Often called the father of supercomputing, he designed a series of computers that held the title of the fastest in the world for several decades. His work was not just about speed, it was about pushing the boundaries of what was thought possible in computation. Thanks for reading No Mic Podcast Scribed by Facelesslingjutsu. Subscribe for free to receive new posts and support my work. Seymour Cray's early career was marked by significant contributions to the burgeoning field of digital computing. After earning his bachelor's and master's degrees in electrical engineering and applied mathematics from the University of Minnesota, he joined Engineering Research Associates ERA in St. Paul, Minnesota, in 1950. ERA had a background in building code-breaking machines for the U.S. Navy, and it was here that Cray quickly established himself as an expert in digital technology. At ERA, Cray was instrumental in the design of the ERA 1103, which became one of the first commercially successful computers for scientific applications. His work at ERA showcased his talent for circuit design, logic, and even early software concepts, a rare combination of skills in one person. In 1957, a pivotal moment occurred when Cray, along with William Norris and others, left ERA, which had become part of Sperry Rand, to co-found the Control Data Corporation (CDC). This move would prove crucial in shaping the future of supercomputing. Initially working from CDC's headquarters in Minneapolis, Cray eventually sought more isolation to focus on his designs and established a lab in his hometown of Chippewa Falls, Wisconsin. At CDC, Cray's innovative genius truly began to shine. He designed the CDC 1604, a transistor-based machine that offered impressive performance at a lower cost than its predecessors, contributing significantly to CDC's early success. However, Cray's ambition lay in building the fastest computer in the world. This pursuit led him to the ambitious CDC 6600 project. The CDC 6600, launched in 1964, is widely regarded as the first true supercomputer. Cray focused not just on processor speed but on the entire system architecture, recognizing the importance of input-output bandwidth to avoid starving the central processing unit. His innovative design, which included peripheral processors to handle I/O tasks, overcame limitations faced by competitors. The CDC 6600 significantly outperformed existing machines and cemented Cray's reputation as a leading figure in high-performance computing. He followed this success with the even faster CDC 7600. Cray's time at CDC was marked by a relentless drive to push the boundaries of computational speed. However, as CDC's focus shifted towards more commercial applications, Cray's desire to build the absolute fastest machines led him to embark on a new chapter in his career. Following his departure from Control Data Corporation CDC in 1972, the next significant chapter in Seymour Cray's career was the establishment of his own company, Cray Research Incorporated. This move was driven by his singular focus on building the world's fastest computers without the distractions of a large corporate environment. Cray Research, with its research and development facilities located in Chippewa Falls, Wisconsin, and business headquarters in Minneapolis, Minnesota, quickly became synonymous with supercomputing. The company's first product, the Cray 1, launched in 1976, was a revolutionary machine. Its distinctive cylindrical design, which minimized the distance electrical signals had to travel, and its implementation of vector processing, allowed it to achieve speeds far exceeding any commercially available computer at the time. The Cray 1 became an icon of the supercomputer era and found critical applications in scientific research, weather forecasting, and national security. Under Cray's leadership, Cray Research continued to push the boundaries of high-performance computing. The company developed a series of increasingly powerful supercomputers, including the Cray XMP and the Cray 2. The Cray XMP, introduced in 1982, was one of the first supercomputers to employ multiprocessing, linking multiple processors to achieve greater performance. The Cray 2, launched in 1985, boasted a massive memory and employed an innovative liquid immersion cooling system to manage the heat generated by its dense circuitry. However, as the supercomputing landscape evolved and competition increased, Cray's relationship with Cray Research also changed. In 1989, he left the company he founded to establish a new venture, the Cray Computer Corporation (CCC), in Colorado Springs, Colorado. At CCC, Cray embarked on the ambitious Cray 3 project, which aimed to utilize gallium arsenide integrated circuits to achieve even greater speeds. Gallium arsenide was seen as a promising material that could potentially offer faster performance than traditional silicon-based chips. Despite the technological promise, Cray Computer Corporation faced significant challenges. The end of the Cold War led to reduced government spending on supercomputing, impacting sales prospects. Ultimately, only one Cray 3 was delivered, and the company filed for bankruptcy in 1995. In the twilight of his remarkable career, even after the setbacks with Cray Computer Corporation, Seymour Cray's passion for pushing the boundaries of computing remained undiminished. In 1995, demonstrating his characteristic resilience and forward-thinking approach, he established yet another company, SRC Computers Incorporated. This new venture marked a significant evolution in Cray's architectural philosophy. Throughout much of his career, Cray had been a staunch advocate for achieving ultimate computational speed through the design of incredibly fast, single-processor systems. His iconic Cray 1, for instance, exemplified this approach. However, by the mid-1990s, the landscape of high-performance computing was shifting. The limitations of simply making a single processor faster were becoming increasingly apparent due to physical constraints like the speed of light and heat dissipation. Recognizing this evolving reality, Cray, with his characteristic intellectual honesty and adaptability, shifted his focus at SRC computers towards massively parallel processing MPP. This architectural approach involves connecting a large number of relatively simpler processors to work collaboratively on a single computational problem. By dividing the task among many processors, MPP systems could potentially achieve far greater overall performance than even the fastest single-processor machines. This strategic pivot indicated Cray's understanding of the future direction of supercomputing and his willingness to embrace new paradigms, even if they differed from his earlier convictions. Tragically, this promising new direction was abruptly halted by Seymour Cray's unexpected death in a car accident in 1996, just a year after founding SRC Computers. This sudden loss marked the premature end of a truly pioneering career. Despite the untimely conclusion to his life, Seymour Cray's impact on the world of computing is profound and enduring. His relentless dedication to the pursuit of speed and his groundbreaking innovations in computer design earned him the well-deserved title of the father of supercomputing. His visionary work laid the fundamental groundwork for the high-performance computing industry as we know it today. The principles and architectures he pioneered, even those he later adapted, continue to influence the design of powerful computers used in a vast array of critical applications, from scientific discovery and technological innovation to weather forecasting and complex simulations. Even after his passing, the companies he founded, Cray Research, which later went through several acquisitions and is now part of Hewlett-Packard Enterprise, and even the nascent SRC Computers, continued to develop and evolve the technologies he championed. This ongoing development serves as a testament to the depth and foresight of his vision, demonstrating the lasting and indelible impact of Seymour Cray on the digital age. His legacy extends beyond the machines he built. It lies in the spirit of relentless innovation and the unwavering pursuit of computational power that he instilled in the field. I talk to myself through the computer. I ask myself questions, leave things to be looked at again, things that you would do with a notepad. It turns out today that it's much better today to do with a personal computer rather than a notepad. Seymour R. Cray. As an inventor, Seymour Cray held patents for some of the technologies and designs he developed. These patents are publicly available through patent offices like the U.S. Patent and Trademark Office and provide insights into specific aspects of his innovations. Some examples of patents associated with Cray include US 2741758A, Magnetic Core Logical Circuits, filed 1953, granted 1956, while at ERA. US 5349677A, Apparatus for calculating delay when executing vector tailgating instructions and using delay to facilitate simultaneous reading of operands from, and filed 1993, granted 1994, with Cray Computer Corporation. Here are some of the underlying principles and approaches that could be considered Crayesque and have influenced subsequent computer design, though not formally named Cray's theory of X. Focus on raw speed. Cray's unwavering dedication to building the fastest possible computers was a driving force behind all his work. Point 2. This relentless pursuit of performance, even at the expense of other factors like cost or ease of programming, was a defining characteristic. Point 3. Vector processing architecture. While not solely invented by Cray, his successful implementation and commercialization of vector processing in the Cray 1 made it a dominant paradigm in scientific computing for a significant period. The idea of processing arrays of data in parallel through pipelined functional units became a key architectural principle. Importance of interconnects and packaging. Cray understood that raw processor speed was only one piece of the puzzle. He meticulously considered how components were connected and packaged to minimize signal delays and maximize overall system performance. Point 4 His cylindrical design in the Cray 1 was a direct result of this philosophy. Balanced system design. While prioritizing speed, Cray also recognized the need for a balanced system, considering memory bandwidth, I/O capabilities, and cooling as integral parts of achieving high performance. Simplicity and elegance in design. Cray was known for his preference for clean, elegant designs. He believed that complexity could hinder performance and reliability. This principle guided his architectural choices. Biographical works. The Superman, The Story of Seymour Cray and the Technical Wizards Behind the Supercomputer by Charles J. Murray 1997. This book provides a detailed account of Cray's life and work, drawing on interviews, including his last one. A Seymour Cray Perspective by Gordon Bell 1997, a retrospective analysis of Cray's impact by a prominent figure in computer history. Seymour Cray, An Appreciation by Toby Howard 1997, a personal reflection on Cray's influence. The Seymour Cray Era of Supercomputers, From Fast Machines to Fast Codes by Boali Elzin and Donald Mackenzie 2025. This book analyzes the development and use of supercomputers during Cray's influential period. Seymour Cray, The Father of World Supercomputer by S.I. Hungway 2019, a historical analysis of Cray's contributions to supercomputing. References. Bell, Gordon November 10, 1997. A Seymour Cray Perspective. Microsoft Research. Howard, Toby February 1997. Seymour Cray, An Appreciation. Personal Computer World. Site Journal requires journal equals help. Murray, Charles J. 1997. The Superman, The Story of Seymour Cray and the Technical Wizards Behind the Supercomputer. John Wiley & Sons. ISBN 978-0-471-04885-5. Pagelkopf, Don, et al. 1975. Reminiscences of Computer Architecture and Computer Design at Control Data Corporation. University of Minnesota Digital Conservancy. Charles Babbage Institute. Discussion topics include Control Data Corporation, CDC 1604, CDC 6600, CDC 7600, CDC 8600, CDC Star 100 and Seymour Cray.
Mics on the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No light, no fame, just the sound we crave. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Hidden in shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go. Pure and raw. Pure and raw.
Cray.